solve the next differential equation. Secant squared of x dy over dx is negative y squared. So we can see that we can separate variables here, and we can rewrite it as dy over y squared is equal to what? Negative 1 over secant squared x dx. Minus may be on the left hand side, it doesn't matter. And then we can just integrate both sides. And on the left hand side we can see that it's usual formula, x to the power of n. Now y is to the power of negative 2, and how to integrate? Applying a formula, it becomes, we add 1 to the power, so negative 2 plus 1 becomes negative 1, and divide by the obtained power, negative 1. And y to negative 1 is just 1 over y. So finally it becomes negative 1 over y is equal to, how to integrate 1 over secant squared. What is secant? Secant, it's 1 over cosine, hence the right hand side becomes just cosine squared. And how to integrate cosine squared? You must know that you must use what? Double angle formula only. And cosine squared is what? Cosine of 2x plus 1 divided by 2, and we can write over 2 in front, so it becomes a half, and cosine of 2x plus 1 dx. And what is integral of cosine? In general, you can see that it's over 2x, so you should apply substitution u, but it's function of ax plus b, so we can just apply a formula as given in the data booklet, keep same argument, but 1 over a rises in front. A is 2 here, because we consider cosine as a function of ax plus b. So it becomes, and negative a half, it's as a common factor, and it's sine of 2x, but with the half in front, plus integral of 1, it's x, and plus constant. We can write here or here, it doesn't matter. Notice that you may write constant on the left hand side, it doesn't matter. And let's divide each term by negative 1, so it becomes 1 over y is plus a half here, and let expand, so it's 1 over 4 sine of 2x plus a half x, and it's minus constant, but negative a constant is just another constant, so we can just write plus c. And to find c we need some point, and a point given is 0, 1, so substituting 0, 1 we get it 1 over 1, 1 is what? 1 over 4 sine of 0 plus half times 0 plus c, so c is 1. So finally 1 over y is this plus 1, and hence y becomes what? 1 over 4 sine of 2x plus a half x plus 1. Or you may solve for y firstly, and with constant, and then find a constant. To find constant at this step, it doesn't matter, and it's the answer. And if you want, you may multiply by, or you may multiply each term by 4 to get 4 over sine of 2x plus 2x plus 4. And the next question proves that secant of x is greater or equal than 1 and less or equal than 1 plus tangent. When you meet secant and tangent, you remember that there exists a formula which relates secant and tangent, and it is given in a data booklet, and it looks like what? Secant squared x is 1 plus tangent squared of x. But we need inequality to arise here, and we need 1 plus tangent, not tangent square, and we need actually secant, not secant squared. But if we have an expression for secant squared, secant is what? Square root. But if it would be 1 plus tangent squared, secant squared, and it must be less or equal, then we can do what? Apply square root on both sides, and hence we get secant is less or equal than 1 plus tangent. But how can we get 1 plus tangent squared, and how can inequality sign arise here? And also you should understand that in general, square root of a squared is a when a is greater than 0 and negative a when a is less than 0. But here everything is positive. Why? Because x is its argument is in the first quadrant, so all trigonometric functions are positive. So when you take a square root, there will be only positive value. So, but how to get 1 plus tangent and then squared? We can see that it looks like formula a plus b squared, but it's 1 plus tangent and squared is what? 1 squared, 1. Tangent squared is tangent squared, but we also need 2ab, 2 tangent. And we can just add 2 times tangent of x on the right hand side. And since 2 tangent is some positive value, secant squared becomes now what? Less or equal than this expression. It looks like when a is 10, if you add 5 on the right hand side, for example, it becomes what? Less. So if a is 10, a is less than 15. Or if a is less than 10, it's automatically less than 15. And in general, it looks like a is less or equal than 10 plus b, where b is greater or equal than 0. We can add that 2 as 2 times tangent of x is greater or equal than 0. And then, since we should note this, since all terms are positive, we can just apply a square root on both sides and get that secant of x is less or equal than 1 plus tangent of x. But here we should also rewrite that it is equal to 1 plus tangent squared. Or rewrite as inequality secant squared of x is less or equal than 1 plus tangent and then squared. So the right hand side, this inequality is proven, but we need this left inequality should be proven. How to prove it? Actually, it can be proven just if you consider secant to be 1 over cosine, and for x from 0 to pi over 2, cosine changes from what? From 1 to 0, and 1 over cosine when this function monotonically changes from 1 to 0. So overall expression changes from 1 inclusive 2 plus infinity. So you may just write in words, but we can also use the same formula. Secant squared of x is 1 plus tangent squared of x, and secant it's what? Just a square root of 1 plus tangent squared of x. And if we remove this term, now what? Secant becomes automatically what? Greater or equal than square root of 1, which is 1, as tangent squared of x is some positive value. It's like when a is 10 plus b, where b is positive. So if we remove or delete b, a becomes automatically greater than 10, or greater or equals than 10, if b is greater or equals than 0. So hence secant is greater or equals than 1, and secant is less or equal than 1 plus tangent of x. So this inequality is proven. Next, deduce that integral over secant of x from 0 to pi over 4 is greater or equal than pi over 4 and less or equal than pi over 4 plus a half times ln of 2. And definitely we can see that we can consider integrals of this inequality, and it's not required to flip inequality signs, or inequality signs remain the same. Why? Again, because everything is positive and all curves of corresponding graphs will be above x-axis, and it means that integrals will be positive. So we can just consider integrals, hence it becomes integral from secant integral of secant of x dx from 0 to pi over 4 is greater or equal than integral from 0 to pi over 4 of just 1 dx, and less or equal than what? Integral from 0 to pi over 4 1 plus tangent of x dx. And this integral, it's quite easy. It's what? It's just x with limits 0 pi over 4 is pi over 4. And this integral 1 plus tangent dx is equal to, how to integrate this? You can see that integral over sum is equal to the sum of integrals. So it's integral from 0 to pi over 4 of 1 dx plus integral from 0 to pi over 4 tangent of x dx. And what is tangent, or how to integrate tangent? We should consider as sine over cosine dx. And it's what? Pi over 4 plus integral. And how to integrate this? You can see that sine is derivative of cosine with minus, so it looks like negative d of cosine over cosine, and actually you can see that it looks like negative du over u. It's called an inverse chain rule, but it's not necessary. You may just use substitution u. And what should be u? U should be cosine denominator. Du over dx, as usual, it's what? Negative sine, and it becomes integral. Limits also change, and it becomes what? Sine dx, it's what? Du over negative sine, and cosine is u. And we can find the limits in terms of u, and then just substitute limits in terms of u, or we can get the integral in terms of u and then rewrite in terms of x and use the previous or limits in terms of x. Let's find new limits. u1 is cosine over of 0, which is what? 1, and u2 is cosine of pi over 4, it's what? It's 45 degrees, that's root 2 over 2. So it becomes what? Integral from 1 to root 2 over 2. And you can see sine cancels, and it becomes pi over 4 plus, what is integral du over u? It's ln, and in general it's the absolute value of u and the minus in front, minus this minus, and limits from 1 to root 2 over 2. To avoid mistakes, you may change limits, and hence it becomes plus here. So it becomes pi over 4 minus, and we substitute upper limit ln of root 2 over 2. It's positive, so absolute value bars not required. And minus, we substitute lower limit ln of 1, which is actually what, 0. And it becomes pi over 4 minus ln of, and it's 1 over root 2, and root 2 is what, 2 to the power of a half, and it becomes what, 2 to the power of negative a half, and we know a property that this moves in front. So it becomes finally pi over 4 minus negative, so plus a half ln 2 as required. So hence you may rewrite that a given integral of secant of x from 0 to pi over 4. Or let's rewrite, hence integral from 0 to pi over 4 of secant of x dx is greater or equal than pi over 4 and less or equal than pi over 4 plus a half times ln of 2 as required. And that's all for this question.